we will see a demo of analysis and design of one-way continuous slab. Okay, so suppose we have a slab like this. It's the Ly is 7 meters and Lx is 3 meters. It is a one-way slab and it is continuous. Then we can take a 1 meter strip like this, and we can design this slab as a 1 meter width beam, right? So first we will do the analysis of this beam, okay, or you can say 1 meter slab which is continuous upon these two supports. Okay, so let us first do the analysis. So for that we'll go to analysis section. Okay, so we will again use the same program, that is the analysis of 2D frame, folded plates or continuous beam. Okay, so there are 3 members and the length of each member is 3 meters. So let us give the coordinate and draw the first member. So x1 is going to be 0, press enter, go to 0, press enter, 2 is 3 meters, press enter, y1 is 0, press enter, right? And you can draw the member, right? Now the second member, x1 will be 3 meters, y1 will be 0, x2 will be 6 meters, y1 will be 0. Okay, so this is the second member. The third member is x1 is 6 meters, y1 is 0, x1 is 9 meters, and y1 is 0. Okay, I can draw the third member. Okay, so this is how we have drawn the continuous beam, that is continuous slab, treating as continuous beam, right? Now click finish. So this is how it says that how the text box are to be numbered, frame joints are to be numbered first, and the support joints are to be numbered at last. Okay, so is the drawing complete? No, we still have to fill the text box. In this case all these are support joints. Okay, there are no frame joints, so number this as 1, 2, 3, 4, right? Click finish, exit. Is the drawing complete? Yes. Have you filled the text box? Yes. Okay, now write the total number of frame joints. In this case the frame joints are 0, so write 0, press enter. Write the total number of supports joint, 4, press enter, right? Now we assume that all the supports are hinge. Okay, so let us take it as hinge. Okay, now so all the text has turned to green because we have taken it as hinge support, right? Now as it is a continuous beam, we will have to use the manual command, okay, to fill the to give the data to the beams, right? So click this command. Okay, press enter key to continue, so press enter key. Okay, so this is the first member, right? Do you want to select this member? Yes. Fill the property table. Okay, so the width is 1 meter. Okay, press enter. Depth, so the depth of the slab is now 100 mm, that is 0.1 meters, 0.1 meter, and it has a UDL of 15 kilonewton per meter square. Okay, so write 15 and just enter and every text box and come out of the form, right? Now we will take this as member number 2. Yes, we select, fill the property table, same, width is 1 meter, depth is 0.1 meter, load is 15 kilonewton per meter square, and just come out of the form. Okay, now this is the third member. We select this and again use the input data. Width is 1 meter, depth is 0.1 meter, UDL is 15. Just come out of the form. Okay, give the file name. You can name this as M. Okay, now run analysis, create input. Okay, input is created, run analysis. So the modulus of elasticity is 2E8, enter, and the load factors are 1, enter, 1, enter, right? Okay, finish. So you can see the output, right? This is the output, and you can see the bending moment diagram. Okay, you can zoom the frame. So this is the bending moment diagram, this is shear force diagram, right? Okay, now you can see the bending moment and shear force diagram for any member. Say member number 2, write 2, enter. You can see the shear force diagram, you can see the bending moment diagram. Okay, and you can find the bending moment and shear force diagram at any point. Okay, or you can write any distance from the initial point. So you want to know the shear force and bending moment at a distance 1.5 for member number 2, press enter. Okay, so the shear is 0 and center, and the bending moment is 3.375, right? So this is how we do the analysis. Okay, after doing the analysis, we go to the design section for the design of continuous beam or continuous slab. Okay, now go to design section, program list, continuous beam. Okay, for one way continuous slab, this is to be run after giving the frame data to the continuous beam on the analysis command, right? So we have done that. Okay, so now we will run this program. Now Fy is equal to 415. Please use enter key, press enter. FCK is at 20, press enter. And now if the depth of the slab is to be restrained, write 1 or else 0. No, we don't want to restrain the depth. Okay, so let us write 0, press enter. Okay, finish. Okay, so here you can see the design of the continuous slab. Okay, for member number 1, okay, the negative AST per 1 meter width is this much, and maximum D. Okay, we had considered the depth to be 100 mm. Okay, but the required is 115.38. Okay, so we'll have to change the depth, right? And the positive moment is this much, and EST minimum is this much. Fy is considered is 415 and FCK is 20, right? So this is related to the positive EST and positive moment. This is negative steel. Okay, on left hand support, this is the steel, this is the moment, sorry, a negative steel in mm square about left hand support is equal to this much, and for moment is 0, right? Okay, so and the negative steel, so we are providing 50% steel of this, right? 50% of this has to be provided. So, and the negative steel in mm square Trident support is 415 mm square for the moment, this much. Okay, this is how the steel has been calculated. Required area of steel has been calculated for this continuous one-way slab. Okay, so you can do the analysis and design of continuous slab by this program, or you can just take this moment which we obtain over here. Okay, and you can use the graphs which we saw in the moment in the program where the moment coefficients are produced. Okay, so in that the second part we saw that we can draw we can do the analysis of slab by just giving the depth of the section. Okay, let us try. Okay, see, I will once again demonstrate. Say we want to find the steel for moment 10.8. Then if you want to go over here, actually the clear cover assumed is 15 mm. Okay, but if the clear cover, you want to change the clear cover, then you can take this moment and just go to this program and you can go to this graphical representation. Say our depth turned out to be 115 mm, right? Click tab. Okay, and say the clear cover we want to take is 20 mm instead of 15. So let us write 20, then press tab. F5 is 415 and F6 is 20. Okay, so calculate. So we can use 8 mm, 10 mm and 12 mm bars in when the thickness is 115, right? Because we are not allowed to use the diameter of bar greater than d by 8, right? So now we want to find the spacing of steel when the moment is 10.8. Okay, just click this button because we are going to use 8 mm bar as main steel, right? Bring 10.8 over here, just scroll this pointer on the black graph, right? Okay, we can see okay, say it is 10.75. So the spacing required is 137 and the steel required per meter is 364, right? So you can always use this program if you want to vary the clear cover. Okay, so the previous section the inbuilt cover, clear cover was taken as 15 mm, but if it is different than that, if you want to take some another value of clear cover, then you can always use this program and get your steel per meter spacing and also check for the one-way shear, right? So we can check for the one-way shear. Now say the EST is 364, right? Then the shortest span is 3 meters. Okay, press tab key. Now the load which we considered was 15 kilonewton per meter square. Okay, now EST was 364. Okay, now let's check. Okay, so permissible is 0.56 and actual shear stress is found to be 0.23. So the section is safe in shear. So this is how you can take the moments from the last section and just check for the spacing and the steel and the shear by this program. Okay, So thank you.